dear friends in DTU, colleagues, but I will mainly say friends, because we have had very, very long relationships. I have had that personal, but also I have seen my colleagues is doing the same. In particular, I have had the pleasure to work very closely with Roberto Mugens for I don't know how many decades, Ulrik, and many, many others. So good to hear from you, all of you. I am actually currently on a research campaign here in the outside of Trøndelag. So I'm sitting in a research base. So in a way, COVID has learned us about we can actually still participate in events like this, and so that is something good about all this. But again, first of all, congratulations with the CCAS. I am extremely happy to be involved, and so we can start. And my background is more on the blue economy. So Roberto, you can start to click. Yeah, so the intention was to go a little bit about reminder what is really the blue economy from our perspective, and then summing up why autonomy in this field and what is the difference between automation and autonomy, testing, verification, and some examples of what we are doing. That is the talk for today. Next, please. I think when we are doing an investment, and Rector did point this out very well, you have your vision for what you are contributing to the society. We do the same. We have knowledge for a better world. It's actually the vision for NTNU, and it is indeed giving me inspiration. So we are using, as you will see, tremendous resources in this field in Norway, and we have to have a holistic view. And even if some of these terms, in a way, may be overused and in some misused, we still have to keep our eyes on the holistic view about global challenges, value creations. We have to have proper management, and then the role of the universities is actually to create knowledge. So next, please. There is no doubt that global challenges such as global warming, greenhouse gases, are serious. But we also, at least what I have learned, is also the important to take care about the ecosystems and biodiversity. Maybe that is an looked and under-addressed problem in all these efforts to look for global warming. But these are connected. Next, please. We have to, both DTU and NTNU, we have a huge responsibility to help the society also to create businesses that for in the blue area is the marine related. But we also have, of course, all other industries, as you are going now to address in this new center. Please, next. And you can take all, just to see the FN, yeah. But what we also see is that there are dilemmas all the way. It is, so the success is very much that the politicians, the rule makers, those making standards are well connected to this holistic view. And for us, I think we should never compromise the importance of bringing knowledge into this. We call this knowledge-based management. And this has to be aligned with the UN Sustainable Development Goals. And from my perspective, these goals is actually the biggest market study ever done. And we see also how different businesses are now making this not to restrictions, but rather to an opportunity for creating new businesses. Next, please. Here, what we have, at least in Norway, you also have that in Denmark, is if you're looking to the blue economy, we call this a supercluster. You have shipping, you have oil and gas, you have fisheries, we have aquaculture, we have tourists, we have a huge coastal infrastructure. We see also how now offshore renewable energy is coming as an important part. But if you are going further into the oceans, we have hardly seen only fractions of the oceans and the potential of oceans for new food, but it is also new medicines, and we have to look into I would say, the health of the oceans, because also we see the oceans are extremely important for the whole climate and life on Earth. So how we should also manage this is crucial. Next, please. Okay, so now a little bit more on the theoretical background from our side. Please, next. You could say the reason for why we go into this and what are we really facing, at least for those of us that has been in this field for a while. We are I would say, in the middle of a digital big bang. Just take next. And this is enabling technologies, which is really creating huge change in daily life and also for universities and for businesses. And I see this is one of the really big enablers why we are speaking about what we do today. There is also coming up other enabling technologies we should keep a very strong eye on, which will be connected to this one. For instance, material technology, biotechnology. So how we, on the university viewpoint, we should, in a way, be the first one to first do research here, but also to start to do integration in an interdisciplinary setting. Next, please. So driving businesses for autonomy, you could say that they are within aerospace, robotics, marine robotics, automotive, next please. And you could say one reason for why these areas have been driver, one thing is, if you look into aerospace and marine robotics, is that you have lack of communication. These units simply have to deal or survive on their own. And that has been one reason for making them, I would say, a higher level of intelligence, going into autonomy. If you go on advanced ships, oil and gas ships, cruise ships, we have been working with autonomous functions for decades already. I spent 10 years of my professional career in ABB. And if you're looking to all safety systems on such units you see there, and if you're looking to a lot of advanced power management systems, to drilling control system and how you interconnect them to the dynamic positioning system. Autonomy is really not new at all. We have actually taken benefit of autonomy typically in cases where we don't have time to think and to interact with the operator. The system has to be dealing with this on their own. Next, please. So that has actually also led to autonomous ships. And what actually was an eye-opener for me, because if you're looking to automation, one reason for automating processes is actually that you are doing things faster. You can reduce what we call the operational expenditures, that is OPEX. But what is also a big difference here is also related to CAPEX. If you're looking to autonomous ships, if I could make these ships without having all this additional, you could say, infrastructure to keep people on board, I could actually also build them cheaper. So that is also a game changer coming in, that you should not only look into OPEX, but also to CAPEX. And what we see is that autonomy is also creating completely new innovation within business models. Because if think you are a ship operator, if you, in a way, are looking to the future, I'm not speaking not on all ship routes, but some segments, you see a trend where the system vendors, the big system vendors, together with the owners, or you could say the client of the operations, they are now starting to connect without any ship operator there. So that is examples we have with Yara Birkeland, where Yara, together with Kongsberg, enter into a new segment, a new business. We see the same with ASCO Maritime, where actually the ASCO, they are called the Norwegian group for consumer markets, are going together again with system vendors. So this is also, you could say, a big business transformation that is taking part. You will see new players are coming up for this, and this is also interesting. But still, of course, the shipping companies has to keep pace on this, but they have to be awake, else they will be out of business. But what is also interesting in terms of this picture here, if you look into maritime, one of the biggest challenges in according with, or for us, is to meet also IMO requirements to reduce emissions with 50% in a global setting. And you will do a lot here regarding machinery systems, optimizing hull, and route planning, etc., etc. But maybe one of the bigger, you could say, enablers also to be successful here is actually that you go autonomous. You could actually just reduce the speed. So we will see new shipping routes is coming up, also in deep sea shipping, that may go with 5, 4, 6 knots. And since you don't have people on board, you don't need to rush that fast. So there is not all goods that needs to be transported with 14 or to 20 knots. So that this is also will be a huge change. If you're also looking into urban and rural transport, we see that we have also to take benefit and use the waterways again to transport people. And they will of course be green. We are speaking about greener ports. So you will see new possibilities coming up. Next, please. So of course there is huge challenges. Are we ready for autonomous ships and ports? Well, I think so. It is easier to go with an autonomous ship if you compare that to an autonomous car. And you have more space. But of course there are numbers of challenges related to cybersecurity, testing, verification. How do we deal with manned and unmanned ships? And will it be, you could say, hybrids of this, where you go unmanned and partly remotely controlled in a part of the route, and then you shift into manned operations or assisted operation. And I think that will be the case. Next, please. What is also coming up, if you're looking not only to autonomous ships, but now I'm going more into robotics, and this is, I will come even more back on this. And we also see that we are setting up new organizations, we could call them robotic organizations, where we actually are having a network and swarms of robots. They could be one type, or they could even be of different types, operating in different domains. So how should the robot helping robot, and how should the collaboration be done? And this is also a huge possibility regarding scalability, where actually also open sources and connectivity, etc., will be crucial to be successful. And I think here we have tremendous of possibilities, and we, in the marine space, we are already starting this in a quite, I would say, determined manner. And now we can go to the next example, where you could see a robot is helping a robot, where you could also be out of the box and being creative. Please start this video. Is it any noise there, or? There
is
no, okay.
No sound coming out from the video.
But I can speak for this video. But what you see here is that use of, in this case, an unmanned aerial vehicle for departure from a ship is easy, but in order to and launching, but in order to land, it's a highly risky operations. So in this case, you see how actually you could still be successful by simply putting the landing outside the ship. And for oil and gas operations, this is extremely important, so you don't have any explosions, etc. Okay, so here you see robots are helping robots. Next, please. What we also have been looking into is what I mentioned, the heterogeneous systems. So we are working, if you're going from remote sensing in space to unmanned aerial vehicles, and also to autonomous vehicles, and then underwater, we see also how could we actually optimize you could say, the control and operation of all these different devices, because they have different capabilities in spatial and temporal domains. And this is could be communication networks. It could be also mapping and monitoring networks for the marine environment, but it can also, of course, also and will and are used also for land operations. So now we can switch to the next. Hopefully the voice is working. There is no voice.
Unfortunately not.
Okay, just run it. But the idea here is actually where we are seeing that by having space operations, and we see this also as a huge explosion in connectivity for communication, but we also see a democratization of the space where small sats in particular is now becoming robust enough, cheap enough, that you actually could make your own satellite. Here you could customize payloads, and they can be typically in operations for 4 or 5 years. Giving new possibilities for sensing and communication where you before will have to be there by ships or other systems. In this example, we are looking into hyperspectral imaging. These satellites are going to be operating in polar orbits, where they actually also will be looking into upwelling areas and also of algas, in order to help and monitor the operations. And of course, there will time to time be clouds there, and they are not able to see below. But so that is a part of that. But if you also are cooperating internationally, they could also be used for that purpose. So here you see where you actually are using remote sensing, and this is hyperspectral imaging, where we by colors are able to see, you could say, that you have new layers coming up. And if you are in situ there, you are not actually seeing this shift in water quality masses. So here you see very good examples where you actually have to zoom out and then zoom in. And I think a lot of the success in collaborating robots is actually where you see they are actually collaborating to have this view. So now you could actually go down and be in situ with you could operate with drones, but you could also start to control unmanned surface vehicles to do that. We can just continue. So if you summarize it here, so you can just click all the way. You see the end. So the drivers we have here, it is obviously what we call dull, dirty, dangerous operations. But we also see that these devices are cheaper, and they are unique, and you can actually do solutions which you actually could not. Also, as Rector mentioned in his talk, you could also enable new functions, new markets. But one of the big success criteria here is actually to go for scalability. This means that you should have open systems, they should be able to interact, etc. And we see that you are actually also not only looking to OPEX, but you could also go into CAPEX and having a change on that. Next, please. Yes, so that's why. And now, next, please. Yeah, you can go through. Yeah. So what is the difference between automation and autonomous system? It is really not a hard borderline here. At least if you're looking to how control has been evolving. If you're looking to the work by Mugens, for instance, on fault-tolerant control, he has been a pioneer in this field, and this is a crucial part of autonomous systems. And finally, I would say, people also in the academia, they have seen it, of course, But finally, the bigger groups are actually now seeing the value of such work to be able to reconfigure, plan, and replan. So if you spoke with Mugens, he could say that I have done this for decades already. But these are essential functions in autonomous systems. But they should also be able to learn, adapt, and if you are speaking with adaptive control, we have been doing that as well. But there is still something new, and that is we are going into a field where you don't have obvious, you could say, decisions. So you are getting into what we call a deliberative world. And here, where also knowledge and how this knowledge is handled becomes a new term. So in a way, we are speaking about the increased intelligence in these systems. Next, please. Yeah, and you can go through all the animations. So there are different levels. These are from defining autonomy. These are defined by US NIST and US DOD. There are also different definitions here where you have 10 levels, you have on shipping 5 levels. But the whole point is that you see there is a different levels where the human, in a way, are less and less involved in the decision making. And we don't go into detail here, but just say that there is not either or. There is a mixture of components of autonomy. Next, please. Yeah, and what I also think is crucial is that people are mixing autonomy with unmanned. Or because an unmanned system, of course there is no operator on board, but an unmanned system could be perfectly well remotely controlled. And many of the ships, actually, you are simply moving the control room from the ship to the land. And with good communication networks, you are controlling the ship more or less as you were on the ship. So of course, but if you lose communication, either it is on the ship itself or in this remotely controlled world, the system has to have capabilities to handle this themselves. So that is also important to be aware of. Not all unmanned systems need to be autonomous. And also manned systems, as I mentioned for oil and gas ships, can have plenty of autonomous functions on board. So this is really not that new. Next, please. There are different elements of autonomy which is crucial, and I mentioned some of them here. There is obvious that one of the most crucial, you could say, areas is actually sensing and situational awareness. And this is related to navigation sensors, and here we see how well the car industry, automotive industry, has in a way been able to scale up with this just to help the driver, but then you also get the cost down, and we could put these sensors also in other applications. Anti-collision systems, but also payload sensors, because if we are, for instance, doing this remote sensing, we are also starting efforts to, in a way, analyze the sensors on the fly. Next, please. There's numbers of these. And in a way, you could say we have what we call reactive control systems, but going further. Take next, please. So the new element is actually that we are building up more knowledge into the control system, as we already have done. Next, please. And you see you actually introducing optimization, learning mechanism, and you are building up the yellow part of the system. Next, please. So I think this is what we, from our viewpoint, has seen about the most critical part, is how do we deal with this perception of information? How do we comprehend this information? And can we project it into future situation and put this into to the systems? That is what this is very much about in research terms. Next, please. So what you see here is actually a control architecture. This could be on a ship, it could be on a robot, where you have different levels of control execution, guidance optimization, but you also have the mission layer. And next, please. And what you see here is the red part on the top. That is where automation comes into play, and where we now cannot work anymore alone as a control engineer. For instance, in marine robotics, I have to team up with the marine biologists in order to start to understand the planning, the replanning. I have to also start to understand the sampling of what they are doing. Next, please. And you can go through this. So, yeah, and next. So the automation or autonomy part is actually about to automate the top level with the lower level. And we have to look into new methods in order to do this in a proper manner. And here I think we have to learn from computer science. So people like me from the control society, we have actually now also much stronger to bridge this into computer science. Next, please. So what you see here is actually a layout from an underwater vehicle, where we have typically on the low level, execution level, are working with the control systems, navigation systems, we have a guidance system, and we have some mission control. But if I'm looking to the AUVs we have today, are using now in the bay, they are quite stupid. We are pre-planning the mission, and then they have a payload sensor, and we are hoping that they are taking good sensor data. And then we take up the robot, and then we start digging into the data, and then we maybe become happy or maybe not. So the idea here is actually that the processing of the payload data should be done more on the vehicle itself. So if there is some glitches in the data, it should in a way go back and take that again. And if you are looking for particular, you could say, species, then you could maybe analyze some of this data, and you go back and revisit it with more advanced sensors in order to have the proper picture. And to the right, you see different, you could say, call it methods, toolbox, which we actually have to deal with. And the yellow one is quite interesting. They are about risk and failure handling. And as already mentioned, with Mugens as one of the big pioneers in fault-tolerant control, you see how also this is coming into play, but also how are you actually putting the seafarers' risk assessment skills into a robot. Next, please. So this is actually, I've come more into that now, but one of the challenges we see here, there is legal considerations, there is social acceptance. Okay, we have created new job places, but we are also taking some away regarding employment issues. But there are safety barriers and risk management, security issues. There's a huge lack of standards of how we should do with this. And then the final question, how should we verify them? How should we test these systems properly? Next, please. So, yes, next, please. So here you see an example of classification of risk. And for our research, we have seen this as, together with situational awareness, maybe as the second most important. How should we classify a risk regarding to mission complexity, to the environmental complexity, and the ability to interact from a human point of view? So here you see, and you will obviously see that different applications are scoring differently in this picture. And so when I'm saying it's easier to drive an autonomous ships compared to a car, you could easily justify it by about both the environmental but also the mission complexity. Next, please. Yeah. So if we if you're from you could say computer control system world, where we normally take a DP system, a dynamic positioning system. Together with Kongsberg, I also launched a company called Marine Cybernetics. We proposed hardware-in-the-loop testing for testing software-based systems. And for a DP2 system, which is pretty complex, there are 4,000 single failure modes that may occur in that system. But if you're looking to it from an operational point of view, there are 4,000 factorial failure combinations that may occur. So it's, in practical terms, infinite. And if you now start to take the next level by using artificial intelligence and all these elements, you actually get, in a way, unless you do this properly, you end up in an uncontrolled environment. And so that is why I'm saying that we need to have methods, both formal. Next, please. We need methods, both formal, where we have to develop theory to deal with this complexity, but we also need, you could say, informal testing methods, where we actually are testing the implementation, not only the design, but the implementation. And everybody working with software systems know there are design flaws. So this is also a huge challenge in this era. And where I'm saying now that, that we have more than before also connect with the software science guys. Next, please. So this is an example where you are using a digital twin in order to, in a way, create, you could call it a virtual test environment where you actually could use computers to test computers. Next, please. What you see here, now I'm going a little bit back to show you some examples. So this is looking to the oceans again. What we see here is processes taking place in the oceans. And there are plenty of those. And if you now take next, and you can just animate to it. In a way, what you see here is that you are going to have robots dealing with both dynamics and trends and what is happening over decades, but also you should have ability to operate from millimeter accuracy resolution to covering the whole Earth. And here you definitely see how the different platforms are in a way connected to each other. Next, please. So what we also see here is that going from this, call it the robotic world, we also need to complement this also with more advanced models. This could be of the oceans, it could be also of the terrestrial areas, whatever. So the combination of numerical advanced models from natural science together with the robotics is what we also see a huge research era coming ahead of us. Could do similar type of thinking in the medicine. Next, please. So what we actually do now, just go through the animation, is that we are now, these days in Norway and in Trondheim, we are working with setting up a fleet of robots where we actually should be able to call that digital oceans. And together with other partners in Norway and also an international play coming up called RevOcean, we are trying to digitize the whole oceans. But here we need to cooperate in order to see the complete picture from pole to pole. Next, please. So this is the Bay of Trondheim. So what we also have been working heavily with now these days, this because I'm now into the examples here, is we have now installed several of offshore equipment, but also if you go to the next one, we have started also to work with subsea docking, where we also see that by having a template submerged, we are able also to keep the robots underwater for a longer period of time, where they could do charging of batteries, but they could also download data and putting up new missions. Next, please. So here you see where we actually just outside the Bay of Trondheim have been putting the world first, I would say, industrial docking station together with Equinor. So this is going now to be used as a maintenance platform for oil and gas installations. If you then supplement this also with floaters, you actually are creating hubs of these stations that could be used for offshore wind farms, for fish farms, where you're doing inspection both underwater, but also having drones, you could do superstructure, infrastructure inspection. And this is also important area where we jointly between Denmark and Norway need to do this together. Next, please. Here you see an example of this docking station with our also newly developed robot called Illume, which is also inspired by biology. Just giving you a picture of that, where we actually see that new novel concepts actually could evolve from this. And now I have another video, but I think we skipped that because you don't have the noise. I will just wrap up to pitch this to innovations. And I think with CCAS, I think also because I mentioned it briefly, I have about 50% of my time from industry, both from ABB but also from startups. And then I have the rest of my time from academia. But sometimes you could say we have what we call market-driven innovations. But you should not underestimate the value of what I call researcher-driven innovations. And what I hope is that you are creating, you could say, an environment where actually you have license to create, and where you actually could do what we call the disruptive changes. And where there is not that hard regime regarding IPR, meaning that you are, in a way, you become only incremental. incremental is still valuable, but the disruptive changes, I expect them to come from university environments and the surroundings about that. So we have tried to do this in AMOS, and if you go to the next. In order to do this, we have to communicate we have to see this picture, both ourselves, but also in relations to our partners. Of course, most of innovations we are giving here is to industry, and it could be governmental agencies, dependent on the field you are. But we should, more than before, in a way, also start to have spin-offs, where we are in a way creating the new industry. And don't expect the industry to do this. This is the expectation I put on the shoulders of NTNU, I put them on DTU. So you should actually increase the ambitions here to create this, and here we can be inspired by groups in Silicon Valley, also in the Boston area, and we have to be far better in this in Scandinavia and Europe. Next, please. And in order to do this, you have to create a culture for this. You have to have acceptance at universities. You have also to have organizations to do this. You need a fund, and we have to do this properly. And I think from overall, we have to be far better here in order to make the society good for people, as your rector mentioned. From almost the center, we have been working very hard to get this up running. So if you go to the next. This is spin-offs from, you see, from CCAS, the first center. And I was not the director there, I was one of the key scientists. But you see here spin-offs from AMOS, where we actually are running out completely new companies. And you may think this is the only innovation, but this is only 10% of the innovation we are doing. The 90 is already with existing in cooperation with the industry. So here, I think we have to be clever together in order to maintain, I would say, the life standard we have in Scandinavia. And we have to work hard. So thank you so much, and again, congratulations. And I must say, I look really forward to work together with you guys.
Thank you very much, Asgeir. I think we have time for some questions, and just a moment, I will bring you up to the audience, if I manage. And yes, so please, the floor is open for questions. If you would like to address any, you can use the microphones that are here. Okay, while, yes, please, Patrizio, there is a microphone here in the middle. You need to open it on the top. Just switch.
Yes. Can you hear me now?
Yeah.
Yeah. Thank you very much. It was a fantastic presentation going through, the needs in ocean science, to the solutions that we have, and also to the societal development in Scandinavia. So, fantastic presentation. I have a question specifically on the ocean science and observation part. So, since I come from DTU and the Institute for Aquatic Resources, DTU Agua, you focus a lot on the needs of operations at sea, but also observations at sea, and with autonomous solutions and also robotics. I was wondering, what is the role of those that are already at sea, like fishermen and aquaculture and transport industry? What type of autonomous solutions that are available already today to fill the gap in observations we have?
Good. Well, in a way, if you're looking to aquaculture industry, to take that, we are very closely connected to many of the main stakeholders in Norway, where actually we are, and if you're going to the different levels of autonomy, as I mentioned. First of all, so in a way we are helping that and doing that, not as a revolution, but more as a transformation. where they are taking more and more systems in use. So one of the most risky operations, for instance, in aquaculture, if you take that example, is that when the people operating them are going on the aquaculture ring and doing maintenance in an environment which is quite risky, and it could be quite windy and very tough environment, we actually replace that with robots. So in a way, you make the life simply better. So that is one example we do, and we are together also with industry actors are putting more and more instrumentation. So in a way, you put better understanding about the fish welfare, but and also pollutions from that, and becoming more efficiency and also in economic terms. So that is one example where we, in a way, are making life easier. But if you go into some, if you take the example of autonomous ships, there we are putting the seaman on land. And there is obviously, you could say, debate going. Are we now taking, are we taking out workplaces and what now? Well, there will be transformations, and I'm quite sure that, and there are some issues regarding that is crucial, but they will happen anyhow. That is point number one. Point number two is that we are actually doing that. We are creating numbers of new workplaces where these people will be having their skills, but they will be doing that from their homes, and they could go home instead of, at the end of the day, instead of being away from the family for long periods of time. But still saying that, I can foresee many new workplaces, but there is a concern in the society that people that is not having these skills, the truck driver, and not saying anything bad with them, but if we end up in a society where you in a way, discriminate people and you're not able to employ and activate all people, we have a huge challenge in our democracy. So I think we should, in our, I would say, inspiration and call it technology, optimistic approach, we should be sensitive to people and which is in a way falling out. Because if that becomes the case, we end up in situations we don't want it. So I think, again, here, this is also a part of the responsibility here. Shifts will come, but we have to be wise, and we have to figuring out how could most people be involved still. And even disabled people can now typically do work they have not been doing before, because we are actually making the work environment better. But I think this is tricky questions, and from my viewpoint, I mean here, again, we need probably help from social science in order to understand more of this picture as well.